Hello everyone, welcome to the Well of Curiosity and to a brand new series, one that is going to combine two of my greatest scientific interests, volcanoes and outer space. I'm going to call it the Volcanologist's Guide to the Solar System. Over the course of the series, we're going to have a look at what volcanoes are, what they can produce, the different types that there are, and where you can find them here on Earth and beyond. To begin with, let's establish what a volcano is. A volcano is an opening in the Earth's surface where magma, a mixture of hot molten rock and dissolved gases, can erupt out from within our planet. In future instalments, we're going to examine them in great detail. But to start with, let's find out why we actually have volcanoes on Earth at all. Now, to do that, we need to go back in time to the beginning of our solar system. Around 4.6 billion years ago, we think that our solar system was nothing more than a colossal disk of gas and dust orbiting a newly formed sun. Over time, these tiny bits of material started to collide and clump together, getting bigger and bigger, until we ended up with a collection of small objects that we call planetary embryos. Now, as even more time went by, these embryos started to collide as well, and we ended up with a collection of planets, including our Earth. As our planet got bigger and bigger, gravity started to take hold, drawing in even more material. All of these collisions released a tremendous amount of heat, and so our Earth was born in a hot, molten state. Now, it is likely in the hot interior of our planet that heavy, dense material started to sink down towards the middle. Elements like iron and nickel sank down to form a core in the centre of our planet, with a mantle of lighter materials surrounding it. For the first few hundreds of millions of years, the surface of the Earth would have been a hot, molten mass of rock. But as time started to pass, the surface started to cool and the first solid land began to form. This is the crust, and this is the part of the Earth that we live on. Even though the outside of our Earth had started to cool, the mantle below was still very, very hot. And eventually the flow of heat started to move the crust above. It cracked like an eggshell into a series of slabs we call tectonic plates. Now, these plates have been moving ever since, some towards each other, some further away, and some sliding past each other. The movement is tiny, normally just a few centimetres per year, but they are responsible for some of the most fascinating things we find in the natural world, including mountain ranges, earthquakes, and of course, volcanoes. The edges or boundaries of the plates is where most of the action happens. There are three different types of plate boundaries that you can find on our planet, depending on how the plates are moving. Let's take a look at them. 1. Divergent or constructive boundaries. This is where two plates are moving apart. Now, this can either cause the land to split apart to create new valleys, or it can be an opportunity for new magma to rise up from within our planet to the surface. 2. Convergent or destructive boundaries. This is where two plates are moving together. Now, this can either crumple up the land as the two plates collide to form a mountain range, like the Himalayas, or, as in a lot of cases, one plate is subducted and sinks down below the other. Now, as this plate descends, it can cause the melting of rocks to produce magma, which can then rise up through the cracks in the rock, collect in magma chambers, which can then feed volcanoes up on the surface. 3. Transform boundaries. This is where two plates are sliding past each other. It's not smooth going, it's often extremely jerky and is a major source of earthquakes. Sometimes two plates will stick and build up lots and lots of energy, which can be released all at once and release devastating quakes. So, much of our volcanism is driven by one of the first two types of plate boundaries, divergent or convergent. And so many of those volcanoes that we find scattered around the Earth will be found either at or near a plate boundary. But you will find some points on the Earth that receive an unusually high amount of volcanic activity that are nowhere near a plate boundary. These are called hotspots. Now, the reasons for hotspots still aren't fully understood, but the most popular theory to explain them are narrow flows of heat called mantle plumes that drive up from near the core through the mantle and rise up to the crust to fuel those hotspot volcanoes. So that, we think, is the driving force behind the volcanic activity here on Earth. In the next episode, we are going to be taking a look at the different kinds of volcanoes that you can find scattered around our globe. I do hope you have enjoyed this first episode of this series. If you have, please give it a like, subscribe to the channel if you're new, and share it with anyone else who you feel may be a fan of volcanoes like myself. I hope to see you all in the next episode. Goodbye for now.